Oh, shout out. Jalen was already thinking about these as like particles. All right. Yes. What do you notice is a difference between the way these two particles look? What do you notice is a difference between the way these two particles look? Nice job, Jalen. Thank you for helping us out with that. Can I have who have I not heard from? Xavier, can I have you unmute? Go ahead and talk to me. What do you notice is different between how these two particles look?
Mute. Currently on audio settings button menu. Press space to activate the menu. Then navigate with.
Great. All right, let's go. Trinity, what do you notice is different between how these two particles look? Kishar, be ready. I'm coming to you. Let's see who we got so far. Great. Kishar, what do you notice is a difference? What do you notice as a difference between the way these two particles look?
The difference of the two particles is one of them is like on the ground, and the other one is like floating in the sky.
Oh, that's interesting. Awesome, right? So yeah, we get a lot of different. One is spaced out, one is spaced out, the other is closer together. Somebody said they're air molecules. One is compressed together. Well, I like that word, compressed. I wonder where else we've seen that word. The particles, some people think the particles are moving. Okay, great. So now let's talk about it. All right. Oh, I saw my slide. Okay. So you are correct, right? And so when you're looking at the particles of a gas, they're more spread out. All right. So you see them spread out, they taking up a little bit more space. Okay. But when you see the particles of a liquid, they're compressed together, or they're all together. And what's happening with condensation is it's turning from a gas to a liquid. All right. It's capturing the moisture in the air and it's turning into water droplets. All right. So in your notes, you should be able to capture that condensation is when it turns from a gas to a liquid. What you're seeing a picture of is the different states of matter. We're going to talk more about states of matter next class. But when you look at the gas, this is one state of matter. And then when you look at the liquid, this is another state of matter. All right. And so now let's talk about what condensation might look like or what you might see outside. All right. So put in the chat if you've ever seen something like this. I'm gonna open up the chat for everybody so we can all see each other's answers. Oh, we got a lot of you could talk to everybody. Jalen said he's seen it. Jason said he hasn't when it gets cold. Okay. All right. Yes. Okay, cool. What about this? When have you ever seen this one? Go ahead and type it into the chat. When have you ever seen this? Okay, yes and no. Shout out to Jalen. Shout out to Neo, Jabril, Drew, everybody who's really trying to get these extra points. Keith, thank you. Keith, talk to me for these. When have you ever seen this, and like what time? You see it in the summertime, in the wintertime. When have you ever seen this?
I see that in the wintertime.
You be seeing in the wintertime, yes, right? Because that's when the moisture in the air is freezing. All right. Nice job. So this is called frost. Okay. So let's keep going. All right, this is a tea kettle. You making some tea, all right? And what comes out? What comes out of the that teapot? Or if you like taking a shower and you're yes, yeah, vapor. Or another word for it is steam. Okay. All right. And this last one, when have you ever seen this?
Mr.
Yeah.
Bangurah.
Hey Keith, if you need something, go ahead and type in the chat for me, all right? Thanks, big homie. Awesome. Yes, this is fog. All right. When you go into school early in the morning, you might see something like this, and it's called fog. All right. So no cap recap. Let's talk about it. Yeah, Keith, you was right. So you just had to type that into the chat. Look at you. All right. Excited, smiling, beautiful. So the first thing we need to know is the state of matter. So earlier you saw the picture of what a gas looks like, and you saw the picture of what liquid looks like. All right. Then the next thing you need to know is condensation. Condensation is the process of changing matter from a gas to a liquid. The last thing you need to know, the second to last thing you need to know is convection. This is when thermal energy makes air or liquid rise and cool. And the last one is conduction, when energy transfers by contact. I'm going to leave this up for about 30 seconds. Please make sure you capture this down in your notes, because this is the important information that we have covered today. So if you already got it, I already wrote it down, go ahead and type it to the chat that you already wrote it down, so we know that we're ready to move on. Oh, we got Liam, we got Drew, Jason, Neve, Miss Mars, Destin got it down. Okay. Nice. We getting some boss scientists here. Let's get it. Good. Jemiah got it down. Nice job. Awesome. Keith, I need you to make sure you get it down. Keith Shard, I need you to make sure you get this down as well. Shout out to the people that already got it down. We're going to go ahead and move on.
All right, everybody. So you might be thinking, yes, Ms. Vazquez, you talked about all this stuff. Yes, Mr. Bangurah, but what does this have to do with the Earth? And I was wondering the same thing. Now, I'm thinking, how does weather happen? How does, if the Earth heats up really, a ton, and water doesn't heat up that much, but it does heat up, how does that affect the Earth? And how does that affect water? So I'm going to ask you guys, do you know what the water cycle is? Good job, Neo. You already got to it before I did. Do you want to unmute yourself and tell me what is the water cycle and what are we seeing in this picture?
The water cycle is liquid, evaporation, vapor right there, precipitation, liquid, and then it starts all over again.
Okay, so what exactly, good job. That's exactly what I'm thinking. So can you tell me two other factors besides what you read? Maybe something that has to do with temperature and maybe something that has to do with particles and how they move about this slide. So the first thing is temperature. Where do you see temperature?
At the bottom.
What does it say at the bottom?
Warm temperature.
Mm-hmm. And so what did we say that happens? Heat goes from
the sun.
Yes, heat comes from the sun, but heat goes from temperature to what temperature?
Cold.
It goes from
warm to cold.
Good, perfect. So what happens to the particles?
They evaporate.
How do they evaporate?
They go from the sun.
They don't evaporate from the sun. So the sun heats up the water, and then what happens to the particles? We learned that last week, right?
1 second. The particles, they spread out.
They spread out and they move because they absorb what?
They absorbed heat.
Good, perfect. So the liquid particles, they absorb heat, they start vibrating, they evaporate. Good. Now, since Keith wanted to unmute himself, does he want to tell me? Yes, Keith. Are you ready to participate? Keith, do you want to tell me what happens? Keith, what happens when the water turns into from gas into rain droplets? What is that word right there?
What's what?
when the water molecules go up into the air, and then they turn into water molecules when they get cold and they fall down. What is that called?
Let's start with a P right here.
It's what's that word is?
Precipitation.
Precipitation.
Good job. But what's another word for precipitation? When you're outside and it's coming down and you're gonna get wet, what is that called? When you're outside and all of a sudden this water is falling from the sky and you're gonna get wet, what is that called?
Rain.
Exactly, it's rain. So precipitation is just a fancy scientific name for rain. Good job, Keith. All right, so one thing I wanted to highlight is, remember, when hot air, it gets hot because of conduction, it rises, it gets kind of cold, and then it comes back down. And all of that is a whole cycle called the convection cycle, and it also causes the water cycle. Let's move on, Mr. Bangurah. So how does this happen? So you have the warm air rising from the ground, then it gets to a colder place, and then it moves back down to the hot air, and that's called, again, convection. And that makes wind. Isn't that crazy? All right, so I have a good question for you. If hot air goes from hot to cold, where do hurricanes start? Because hurricanes are just hot air moving really, really, really fast. Now, September is hurricane season, so you're going to hear a lot of these crazy hurricane names. So can somebody raise their hand and unmute themselves and tell me, if we know that air goes from hot to cold, where do we think that hurricanes start in the world? And you have a little map over there, so maybe we can think about it. Where do hurricanes start? Xavier, do you want to mute yourself and see if you can share that? Where do you think is hot? Where is hot in the world? All the time. Xavier, I want to hear your voice. I know you have smart ideas. Tell me, where is hot air? Where is the heat in the world?
You can give a country, you can give a location.
Yeah, you can give a country, you can give a location, you can tell me, I don't know, maybe somewhere you know that's always really, really warm. Liam, do you want to unmute yourself and tell me, maybe you know? Where in the world is it really, really warm? What continent, what country, what place have you heard is always warm?
Africa.
Good, Keith. I love the answer, but make sure it's in the chat. You can't unmute yourself, okay? Liam, tell me, what?
I see on the top of the screen that is Puerto Rico.
That's a good idea, yeah. Good. So exactly how Keith said, Africa gets really, really hot, and the Caribbean gets